Okay, we are going to do practice test 1.5 to 1.7. So if you want to get that sheet out and a sheet of paper, you can work along with me. There's no way you're going to get this done on the paper itself. So you're going to need another sheet of paper, and here we go. We are going to start by graphing -2 f of x using the curve that is on the paper. This is practice test 1.5 to 1.7, which is the second to the last page in your packet. It's called practice test. So we're going to use the picture that's been drawn and sketch -2 f of x. Now, two things are happening here. First of all, we're going to go upside down. That's what this negative does. And it's going to be 2 times as tall. All right, that's a vertical stretch. So, upside down and 2 times as tall. So the original picture as drawn, everything's only 1 unit tall. So now everything's going to become 2 units tall. So this little triangle is going to be upside down and 2 units tall. That semicircle is going to be upside down and 2 units tall. Now this little segment just stays the same. It's not going anywhere. It's on the axis, so we can't flip it upside down. And then this triangle is upside down and 2 units tall. So that is a picture of A. All right, so now we're ready for B. B is 2 steps. And I'm going to do this one in 2 steps because it's just too much for me to do it in one. So first of all, I'm going to deal with the negative. The negative is going to take the entire picture and flip it across the y-axis. This is a y-axis flip. So, in the original picture, the triangle that's over here on the right, and nothing is stretched or anything, so everything is still the same size. But the triangle that was on the left is now going to get drawn on the right. And the circle that was on the right is now on the left. There's that little horizontal bar again. And then I have my downward triangle. So that is a picture of this much. Now I'm going to pick everything up 2 units. So this point goes up to here. So my triangle is up here. My circle is up here. Not a very good circle. There's my bar. And then here is my lower triangle. So that would be a picture of f of -x plus 2. Not this part. All right, now we got C. Now again, like I did that one in 2 steps, you can do all these in 2 steps if you want. What's happening here? It's going to be half as tall, and it's going to be moved 2 units to the right. So, if I just jump in and look at it, the original triangle, okay now, everything in the original goes between -1 and 1. Everything's just 1 unit tall. Well now, everything is going to be half a unit tall. Okay, because of that. And it shifted 2 units to the right. So the first thing I have there is my little triangle that was over here on this side. But if I move that 2 units to the right, it is going to look like this. There's my triangle, shifted 2 units to the right. And then I have my circle. And then I have my little bar thing. And then I have my downward triangle. But everything is half as tall as it was before. So it's definitely shorter and shifted 2 units to the right. says I'm going to take the absolute value of the whole function. All right, so I'm going to go ahead. I haven't drawn my original yet on the board. I'm going to go ahead and draw my original, which, okay, so we got this triangle. We have this circle, that bar, and that triangle. All right, so there's the original. Now I am going to take the absolute value of that picture. Everything above the x-axis is going to stay put. So this and this and this little bar here are fine. The only thing that's going to change is this guy has to be folded up. So that is a picture of the absolute value. When you take the absolute value of the whole thing, you just take anything that's below the x-axis and fold it up. Everything else stays exactly the same. Now I'm doing f of 1/2 x. Okay? So this divides the horizontal. But dividing by 1/2 is the same as timesing by 2. So we're really going to make it twice as wide. That's the impact. It's going to be twice as wide. Everything's going to stay where it is, you know, in terms of left side, right side, top, bottom, all that. But it's going to be twice as wide. So the triangle that's over here, instead of being, excuse me, instead of being 2 across, it's now going to be 4 across. So there's the triangle. Likewise, the circle that was 2 across is now 4 across. The bar that was 1 long is now going to be 2 long. And the down triangle is going to be 4 wide. There we go. So there's a picture of the stretched out curve. Okay, now we got the backwards. I have drawn some picture here. And our job is to figure out what I did to the original. So let me look at the original again. This was the original. That's the original. And this is my new version. Now, let's see. Looks to me like it's been turned upside down. Would you agree that the triangle and the circle are now down instead of up? So it's been turned upside down. So I'm just going to make a list. It's upside down. All right, what else has happened to it? Well, it seems like it's been shifted. Let's see, the triangle and the circle did meet at the origin. Now they meet here. So it looks like we've gone left 1 unit. Has anything else changed? We're left 1. I think it's still the same height. Okay, so I need to write an equation, y equals, here's f of x. Now I need to do something to that. Now, upside down, remember to go upside down, reflect across the x-axis, you have a negative out in front. To go left and right, you have to do something to the x itself. So if I'm going left 1, that would be +1. That would move my picture to the left 1. So there's the equation that would generate that picture from that original, right there. All right, good. Now we're going to find the inverse of all of these. And for each of them, if you want, you can switch your variables and solve for y. There's your inverse. That was easy. Switch your variables and solve for y. Switch your variables. Now, solving for y, okay, so we're going to add 10. And now take the square root. And there's your inverse. Now, enlist the domain. I haven't been doing this. Let me catch up here. The domain of the inverse, yeah, the domain of the inverse. Okay, let's think about this. The domain of this inverse is all real numbers. There is nothing to interfere with, I mean, I can't get a negative under a radical. I can't get a 0 in the denominator. All real numbers for that guy. This one is a little bit different, though. This one, x plus 10 has to be bigger than or equal to 0, so x has to be bigger than or equal to negative 10. And then finally C. This was on our quiz. Most of you had a quiz with this on it anyway. All right, so we'll switch our variables. Remember, this is y. All right, so let's bring that over. So we have 3xy equals 2y minus 1. Now let's put everything with a y on the same side. Oops. Put everything with a y on the same side. Now we can factor it out. And now we'll divide. So y is equal to negative 1 over 3x minus 2. And what's my domain? 3x minus 2 cannot be 0. So x cannot be 2/3. That's the domain of your inverse. Number 3. Now this is a super simple problem. You don't have to show any work. Remember that when we say f of 4 is 6, that's the ordered pair 4, 6. So now the question says, let's do the inverse. F inverse of 6 would have to be what? Well, remember what inverses do. They interchange or switch x and y. Think about what you did here. You switched x and y to find your inverse. So that ordered pair would be 6, 4, which means if you plug in 6, you will get out 4. That's what it means to be an inverse. The ordered pairs switch. The functions undo each other. So if 4 turned into 6, 6 will turn into 4. And that's the answer. Easy as can be. Now, your job in number 4 is to prove that these things are inverses. Now, we did this in class one day. If you are proving they are inverses, you must do the composition f of g of x and the composition g of f of x. You have to do them both. So you're going to do the composition of g into f and f into g. Now, what's going to happen when we do that? Well, ideally, they're both going to turn out to equal x. If they don't, then we have a problem. So let's see if this one works out. So f of g of x means plug in x minus 1 over 2, plug g into f. Plug g into f. So I would end up with 2x minus 1 over 2 plus 1. Now don't panic. Look, the 2's cancel. What are we left with? X minus 1 plus 1, which is x, what we wanted. All right, now go the other way. Plug f into g. So we're going to take f and plug it into g. So 2x plus 1 minus 1 over 2 is 2x over 2, which is x. So you just proved those two things are inverses. If your job is to prove two functions are inverses, you must build them in composition. Plug g into f, plug f into g. And you should end up getting x both times. All right, number 5. How many cups of this Kool-Aid added to this of this to get this? Okay. So my strategy may be different than yours, but I'm going to do amount times percent plus amount times percent equals amount times percent. That's how I am choosing to do the problem because it works for me. If something else works for you, great. So I have a 38% solution and a 52% solution. And I got the hiccups again. And I'm going to end up with a 45% solution. Now, one of the amounts is known. What's known? 10 cups of 52. I have no idea how many cups of the 38, but I do know that I'm adding these two together. So if here's my bucket, if I pour in X cups and then I pour in 10 cups, how much do I have of the mixture? X plus 10. I poured in X and I poured in 10. So all together, I have X plus 10. So 0.38X plus 5.2 equals 0.45X plus 4.5. So 0.07X, I probably should be doing a calculator here, equals 0.7, negative 0.7. I am not trusting my arithmetic. I should be able to, but at my age, okay. Okay. So I end up with X equal to positive 10, and I can't remember, was that cups. So 10 cups of the 38% have to be added to give you what you want. All right, the retail price of a Goodwill jumper is $5. Jumper's on sale for 65% off, and there's a 7% sales tax. How much will I pay for the jumper? So I've got $5. I'm going to lose 65% and gain 7%. That's basically what's happening in the problem. It's not going to go to the store, which you've done a lot of times. Bought stuff on sale, had to pay tax. All right, so you rely on the cash register to do it, but what's really going on? Well, we're taking our $5 and we're multiplying it by 0.35. Now, before you start getting all confused, stop. If there is a 65% discount, that means I am not paying 65%, which means I am paying how much? 35%. If you multiply by 0.65, you are not finding what you're paying. You're finding what you're taking off. I don't care. I want to know, what am I paying? So I'm going to multiply $5 times 0.35. That's how much I'm paying. But I'm going to have to pay tax on that too. So I'm going to multiply that by 1.07. What's 1.07? It's what I'm paying, 100%, plus 7% more. I'm paying 107% for this jumper because I'm paying what I was going to be paying, 100% of that, plus an additional 7%. So that all multiplied together will be the answer to the question. 5 times 0.35 times 1.07. So, oh my goodness, I need to go buy this jumper. It would be $1.87. I'd be paying $1.87 for that jumper. That's a good deal for a jumper. Take it from me. All right, consider the function described by, oh, wait a minute, let me back up over here again. When you discount, it's 1 minus the discount, so 1 minus 0.65, that's how I got the 0.35. When you add additional cost, it's 1 plus the percentage, that's how we got 1.07. All right, now I've got parametric equations. And I'm going to write the equation of the singular rectangular equation described by these equations. In other words, I need x, an equation that has just x's and y's. So I got a couple of options. What I might do is square both sides here. And then I can plug that in, so y equals x squared minus 3. If I square both sides to get t by itself, then I can take this and plug it in for that t. So there is a version of your single rectangular equation. Rectangular means Cartesian, x and y. There it is. All right, now what is the domain and range of this function? Now, this is a tricky one because if we look at just this, we would say the domain is all real numbers, but it isn't. Go back to the beginning to where this all came from, which is right here. This is where your x's came from. Notice that x equals the square root of t. So x has to be greater than or equal to 0. Why? Because no matter what you put in for t, x is going to be the positive square root of that. So if you put in 4, you get 2. If you put in 16, you get 4. Every number you get out for your domain is going to be greater than or equal to 0. The range, this is your domain. The range, now think about this for a minute. You can only use positive t's, so 0 is the smallest t, so your range has to be greater than or equal to -3. You're not going to have all range values. That really makes sense when you think about this parabola right here. What about this parabola? There's your squaring function. What have you done to it? Dropped it down 3? Doesn't it make sense that all of the y values would have to be bigger than or equal to -3, since you've got a parabola opening up from that point? It's tricky stuff, but think about it. Just think about it and you can figure it out. Number 8. This is our handy dandy absolute value function. Is it 1-to-1? No, it is not 1-to-1. Why? Because it doesn't pass what? If you said the horizontal line test, you are exactly right. In order to be 1-to-1, you have to pass the vertical line test, which it does, but you also have to pass the horizontal line test, which it does not. This is not a 1-to-1 relationship. Number 9, describe the transformations that would change this curve into this one. All right, so, I got a hole punched in the middle of mine, but I think the original is this. I think that's the original. And I am heading toward this. And I need to know what has to happen to make that happen. So let's look at what this is. This is a parabola, squared parabola. It's upside down, and it's been shifted 2 units to the right and 1 unit up. So if I drew a picture of it, it would look like this. 2 units, I said right, and I meant left. 2 units to the left and 1 unit up, and it's upside down. That's my starting point. Now I got to get from this to this, which is a parabola, opening up, no negative, shifted left 3 and down 4. So you need to tell me what I need to do to get from here to here. And I think there are 3 steps to it. I think there are 3 things that need to be done. The first one is we need to flip it over. So we need to flip across the x-axis. We need to flip it this way. What else needs to be done? Well, this one's vertexed at -2, this one's vertexed at -3, so we have to shift or move 1 unit left. We're talking about getting from here to here. So we flipped it, now it's going in the right direction. Now I'm shifting it from -2 to -3, so that's 1 unit to the left. And then I'm taking it from 1 to -4, so that would be shift or move 5 units down. If you started with this parabola and you did these things to it, you would end up with that one. Does that make sense to you? Start with this, flip it, move it 1 unit to the left and 5 units down, and you would end up with this picture right here, this equation. And finally, last problem, which on the test is the first problem, we're going to build a box. So we're going to take this piece of paper that's 14 by 16. We're going to cut corners out. We'll let the dimensions of the square corners be x. And we're going to build a box. So here we go. What is our equation? And we need the domain. And then we'll figure out what the answer is. Here we go. What's my equation for my volume? Volume is length times width times height. So the length of my paper was 16, but I cut a chunk out of both ends. So 16 minus 2x. The width of my paper was 14, But again, we took a chunk out of both ends, so it's 14 minus 2x, and the height is x. When you fold these flaps up, this is how tall the box is going to be. It's going to be x tall. Length, width, height. There's your equation. Now, what's your domain? In other words, what does x have to be between? X can't be everything in this problem. There are limitations on x because your paper is 16 by 14. So clearly x has to be bigger than 0. You can't cut out negative corners. And x has to be less than, if you said 7, you're right. Because the shortest side of the paper is only 14 units wide. You're going to take a piece out of each corner. The biggest that piece could be is everything up to 7. Because as soon as you get to 7, if you took 7 off this side and 7 off this side, you wouldn't have anything left. So whatever it is, it has to be less than 7. That's your domain. When you graph this, this is going to be x min and x max. You know that y min will be 0 because y represents the volume, and the volume can't be less than 0. And y max, we're just going to take a guess and hope to see on our paper a picture that looks like this. And we'll adjust that till we see this. All right, so here we go. I'm going to put it on my calculator. Don't forget the parentheses. If you're going to multiply it out, that's fine. But if you're not going to multiply it out, which I wouldn't if I were you, make sure you put in those parentheses. Okay. I used 200. That's not big enough, so I used 300. 300 works. So I used 300 for my y max in order to get the picture. Now I'm maxing. Second calc, max. Left bound, right bound. And I came up with 2.48, 247.51 as the coordinates of my maximum. I hope that's right. Now, what was the question? What is the maximum volume? In this ordered pair, remember, when you find the max, you're always going to get an ordered pair, an x and a y. Remember, in this problem, x is the cutouts, the size of the cutouts, and y is the volume. So if you want the maximum volume, you would say 247.51 cubic inches. That is the maximum volume. If it said, if the question had been, how big do the cutouts have to be? The answer would be 2.48 inches. But it said, what's the volume? So that's our answer. Yeah, the rest of that stuff we don't need to be worried about. That is our practice test. Make sure that you know everything on there, and I hope you're having a great weekend.